Right now, as you sit there, 130 million miles from the pale blue dot we call home, something is unfolding that defies every chapter of our cosmic rulebook. Imagine an object, a monolith of ice and rock the size of Manhattan Island, hurtling through the vacuum of our solar system. Its speed is almost incomprehensible, 210,000 kilometers per hour. To put that into perspective, it could cross the entire continental United States, from New York to Los Angeles, in about 90 seconds. But it's not just its velocity that has captured our attention. This visitor is bleeding light, spewing glowing metal into the void, and its very breath is wrong, composed of more frozen carbon dioxide than water, a chemical signature from a place unimaginably different from our own. And just 2 weeks ago, this enigmatic wanderer took a direct hit from a solar eruption so powerful it should have shattered it into a trillion pieces. It didn't even flinch. This object is named 3I Atlas, the third confirmed interstellar visitor to our solar system. And as we gather more data, a quiet but persistent concern is rippling through the scientific community. It's behaving as if it knows exactly what it's doing. We are left with a stark choice. Either everything we thought we knew about comets is fundamentally wrong, or we are witnessing something far more interesting, and perhaps far more profound, than a simple ball of dirty ice. Let me take you back to where the story truly ignites. The date is October 27, 2022. The comet is at perihelion, its point of closest approach to our Sun, the most vulnerable moment in its long journey. At the same time, Russian astronomers at the prestigious Space Research Institute are tracking something else, something monstrous. One of the most massive coronal mass ejections, CMEs, of the current solar cycle, a colossal wave of superheated plasma, is barreling directly toward 3I Atlas. This isn't the gentle solar wind that creates the auroras. This is a cosmic shotgun blast. A wall of charged particles, a billion-ton cloud carrying the raw energy of millions of nuclear bombs, is traveling at millions of kilometers per hour. To give you a sense of its power, these are the very events that can cripple power grids and fry satellites here on Earth, from the supposedly safe distance of 150 million kilometers. This object was about to take that blast point blank. The question on every astronomer's lips was simple. Will it survive? History tells us no. Most comets that brave such a close pass with the Sun don't fare well. They are fragile things, loose agglomerations of ice and dust. Under the immense gravitational stress and thermal shock, they fragment, they dissolve, they simply cease to exist as coherent bodies. So what would happen to this interstellar traveler, already a gallery of bizarre behaviors, when stress tested by the most violent force in our solar system? The data streams poured in from observatories around the globe. The plasma cloud struck. The cosmic hurricane made landfall. And 3I Atlas did nothing. It didn't even flinch. Not only did it survive the onslaught, it held its course with geometric perfection. No deviation, no fragmentation, not a single detectable change in its behavior. It was like watching a battleship navigate a tsunami without so much as adjusting its rudder. The Russian team, in their subsequent report, released a finding that was as reassuring as it was deeply strange. Their statement read, "The signal is exceptionally weak, but 3I Atlas remains on its calculated trajectory." Let's pause on that word, exceptionally. That single adverb is doing an immense amount of work. An object of this nature, after an impact of that magnitude, should be screaming across every wavelength of the electromagnetic spectrum. It should be a chaotic, flaring beacon of debris and superheated gas. Instead, it was barely whispering. Its survival was a testament to a structural integrity that seems almost impossible for a comet. This reminds me of the storms we face in our own lives. We all have moments when a coronal mass ejection is headed our way. A personal crisis, a professional catastrophe, a profound loss. The world watches, and we ourselves wonder, will I survive this? We feel fragile, like we might fragment under the pressure. Yet like 3i Atlas, we sometimes find a core of unexpected resilience within us, an integrity we didn't know we possessed. We emerge from the storm, perhaps with a weak signal for a while, but still on our path. This object teaches us a powerful lesson about the nature of strength. It isn't about being immune to the storm, it's about having a core so solid that the storm cannot alter your trajectory. What is your core made of? When the plasma of life hits you, what is the fundamental principle, the unshakable belief, that keeps you on your calculated path? But the story gets stranger still. To understand the comet's impossible resilience, we have to rewind just a few days, to an event that is perhaps even more baffling. On October 15th, 3i Atlas passed within 12 miles of Mars. Let that sink in. 12 miles. That is closer than most of our satellites orbit the Earth. It's not a flyby, it's a cosmic thread-the-needle maneuver. This incredibly close pass brought it into the crosshairs of NASA's Mars Reconnaissance Orbiter and its HiRISE camera, one of the most powerful imaging instruments humanity has ever sent into space. At that range, the resolution should be breathtaking. We should be able to see surface features, craters, the vents of its active jets, perhaps even variations in its composition. We have, in our possession, photographs of an object from another star system taken from a mere 12 miles away. So where are they? This is where a professional silence descends, a quiet that speaks volumes. NASA hasn't released the images. The official reason is that they are under internal review. But in the world of space science, a delay like this for images of such monumental importance is highly unusual. The researchers who have seen them are tight-lipped, offering only tantalizingly cryptic phrases, hinting that the data could reveal new details about the comet's jets and surface. Let's parse that language. In science, could reveal is not a synonym for might show. It is a deliberate, carefully chosen phrase. It implies that they have already seen something significant, something that challenges existing frameworks, and they are struggling to understand it, to contextualize it before presenting it to the world. Could reveal means the potential is already confirmed. The revelation is simply pending interpretation. They've seen something that doesn't fit. This situation mirrors so many aspects of our quest for knowledge and truth in our own lives. We often encounter locked files and internal reviews. It might be a family secret everyone knows but no one speaks of, a corporate culture where problems are hidden rather than addressed, or even our own psychological blind spots that we refuse to confront. The truth is there, captured in high resolution, but we are not ready or not willing to look at it. The story of the Mars images is a powerful reminder that the biggest barrier to discovery is often not the lack of data, but our inability to process what that data means, especially when it threatens to overturn our most cherished beliefs. What unseen images in your own life are you waiting to confront? What truth is locked in an internal review within your own mind, waiting for the courage to be seen? Even without those images, what we already know is enough to break every rule in the astronomical textbook. Let's travel back to August 14, 2025. The Very Large Telescope in Chile, a marvel of modern engineering, is tracking 3i Atlas, while it's still nearly 4 times farther from the Sun than Earth is. At that desolate distance, in the cold, dark void, the comet should be nothing more than a frozen, inert chunk of ice and rock. It is simply too cold for anything interesting to happen. But the telescope's spectroscopes, which analyze the chemical fingerprint of light, detected something impossible. A clear, unmistakable signature of glowing nickel vapor. Not trace amounts. A veritable aura of gaseous nickel surrounding the comet. The researchers who made this discovery, Rohan Rahatgaonkar and Daryl Seligman, were staring at data that made no physical sense. In the cosmos, Nickel and iron are twins. They are forged together in the hearts of dying stars. They condense together in planetary formation. They melt together, and they vaporize together. Every single object we have ever studied, comets, asteroids, meteorites, that contains nickel also contains iron, usually in predictable ratios. It's one of the most reliable patterns in planetary science. Yet, 3I Atlas is vaporizing nickel without any corresponding iron signature. This is a violation of the basic chemistry of how these materials behave. It is like finding smoke without fire, or shadows without light. Rahatka Onkar and Seligman, faced with this impossible observation, proposed a theory. Perhaps the nickel isn't pure. Maybe it's locked within some kind of exotic, unknown molecule that is incredibly fragile, easily broken apart by the faint ultraviolet light from the distant sun, releasing the nickel atoms at extremely low temperatures. It's a plausible hypothesis, a noble attempt to explain the inexplicable. The only problem? We have never seen these molecules. We don't know what they are, where they would come from, or how they would form. It is an answer that only creates a cascade of new, more profound questions. This scientific conundrum is a beautiful metaphor for the process of innovation and problem-solving in our own lives. We are often faced with data that does not make sense, a business strategy that fails despite perfect execution, a relationship that falters for no apparent reason, a personal habit we can't seem to break. Our first instinct is to find an explanation that fits our existing models. But sometimes, like with the nickel vapor, the problem isn't in our data, it's in our model. The solution doesn't lie in tweaking the old way of thinking, but in hypothesizing something entirely new, an exotic molecule we haven't considered before. It requires us to have the courage to say, maybe the rules I thought were absolute don't apply here. This is the essence of a breakthrough, the willingness to entertain an explanation that creates more questions than answers, because those new questions are the gateway to a deeper understanding. But let's assume for a moment that the scientists are right. Let's say 3I Atlas contains some unusual nickel-bearing compounds. That's a fascinating scientific curiosity, but it's not yet alarming. Then, the James Webb Space Telescope, humanity's most powerful eye on the universe, turned its gaze toward the object, and everything became infinitely more complicated. The JWST doesn't just look at things, it dissects them. Its infrared instruments are so sensitive they can identify individual molecules in a comet's atmosphere from hundreds of millions of kilometers away. Scientists expected to find the standard interstellar ice cream recipe. Lots of water ice, some carbon dioxide, and trace amounts of methane and ammonia. What they found was completely backwards. The coma, the cloud of gas surrounding the nucleus, contained significantly more carbon dioxide than water. Not a little more, a lot more. In all the comets originating from our solar system, water is the dominant component, making up 80 to 90% of the ice. 3I Atlas had flipped the script. It is fundamentally a carbon dioxide comet that just happens to have some water in it. This has profound implications for where this object came from. Comets are frozen time capsules. Their composition tells the story of the stellar nursery where they were born. Water-rich comets, like the ones we know, formed in a Goldilocks zone, where water could freeze but other, more volatile gases could not. Carbon dioxide requires much colder conditions to freeze solid, an environment far more frigid than the formation zones of our own system's comets. The researchers, Rahatka Onkar and Seligman again, concluded that 3I Atlas must have formed billions of years ago in an extremely cold region around another star, in conditions colder than anything in our outer solar system. They even suggested it might predate our own sun. Stop and consider that for a moment. This object, this visitor, could be older than our entire solar system. It could have been wandering through the blackness of interstellar space when the Earth itself was just a formless disk of dust and gas around a newborn star. But here's the paradox they don't spell out in the scientific papers, the part you have to read between the lines. If it was born in such an extreme deep freeze, and if it has spent billions of years in the near absolute zero temperatures of interstellar space, why is it so astonishingly active now? This ancient deep frozen visitor should be the last object we'd expect to see putting on a show. It should be dormant, inert, barely reacting to the sun's heat. Instead, it is the most hyperactive interstellar object we have ever observed, releasing gases and metals at distances where other comets lie sleeping. The contradictions were piling up. Then came the tail. In September 2025, the Nordic Optical Telescope in the Canary Islands captured images that made absolutely no sense. The comet had developed an anti-tail, not a regular tail of dust and gas that streams away from the sun, pushed by the solar wind, but a distinct spike of material pointing directly toward the sun. Now, anti-tails are not completely unknown. They are typically an optical illusion that occurs when Earth passes through a comet's orbital plane, allowing us to see a trail of heavier dust particles left behind in its orbit, which from our perspective appear to point the wrong way. It's all about viewing angle. Perfectly normal, perfectly explainable. Except the anti-tail of 3I Atlas didn't behave like an optical illusion. It appeared, it strengthened, and then, impossibly, it began to rotate. By late September, telescopes worldwide watched as it transformed, seemingly in a controlled fashion, into a regular tail streaming away from the sun as expected. This is where Dr. Avi Loeb, the former chair of Harvard's astronomy department, entered the conversation. Loeb has become a lightning rod in the community for his willingness to entertain unconventional ideas, particularly about our first interstellar visitor, Oumuamua. He is not a fringe blogger. He is a highly respected tenured professor from one of the world's most prestigious institutions. And he did not mince words. In his analysis, he argued that the anti-tail's appearance, its strengthening, and its rotation were inconsistent with simple random outgassing from a spinning nucleus. That would be chaotic. This, he suggested, appeared almost deliberate. It resembled, in his words, controlled maneuvering. Loeb doesn't claim it's definitely a spacecraft. He proposes that we must consider it as one possibility among several. He outlines two scenarios. Either its intentions are benign, or they are not. And he suggests, with a chilling pragmatism, that we should probably figure out which one it is before it gets any closer. Naturally, most of the astronomical community pushed back, hard. They argued that a complex interplay of the comet's rotation and the geometry of its dust ejection could explain the phenomenon. They are probably right. Occam's razor, the principle that the simplest explanation is usually the correct one, demands that we choose unusual comet behavior over alien spacecraft. But here is the crux of the issue. Even the most ardent skeptics struggle to explain all of 3I Atlas's bizarre behaviors with a single, coherent model. The nickel without iron, the inverted water to CO2 ratio, the extreme hyperactivity at vast distances, the geometric perfection of its trajectory after a massive solar impact, the rotating anti-tail. Individually, you can perhaps find a convoluted, hand-waving explanation for each. But to find all of these anomalies together, in one object, that's when scientists start to quietly admit, off the record, that they don't have all the answers. This entire scientific debate around 3I Atlas is a microcosm of how we should approach complex problems in our own lives. We have the one mainstream explanation, the safe conventional wisdom that explains most things. Then we have the Avi Loeb hypothesis, the radical, outside-the-box idea that seems crazy at first, but addresses the anomalies that the conventional wisdom ignores. Most of the time, the mainstream view is correct, but progress, real, transformative progress, only happens when we have the intellectual courage to entertain the radical idea. We need to be able to hold two conflicting thoughts in our minds. This is probably a natural phenomenon. And what if it's not? Flyby, this intellectual flexibility is not a sign of weakness. It is the hallmark of a truly open and curious mind. It's about respecting Occam's razor, but also remembering that razors can sometimes be too dull to cut to the heart of a truly new mystery. Amidst all this high-stakes mystery, the presence of 3I Atlas has provided a remarkably practical and urgent opportunity. The International Asteroid Warning Network, IAWN, a global coalition of observatories and space agencies, has launched what they are calling the Comet campaign. CO, from November 27, 2025, through January 27, 2026, they are coordinating an intensive worldwide observation program. But their primary goal isn't to study the comet's exotic composition or debate its origin. Their goal is to refine our ability to track it. Here's why that is so critically important. When we talk about planetary defense, protecting Earth from a catastrophic impact, the absolute first step is knowing exactly where the threat is and where it's going. With asteroids, this is relatively straightforward. They are solid, predictable chunks of rock or metal. You can pinpoint their center of mass, calculate their orbit with high precision, and predict their position years, even decades, in advance. Comets, on the other hand, are a tracker's nightmare. They are chaotic and unpredictable. Their bright tails and comas obscure the nucleus, making it hard to find the precise center of mass. More importantly, they outgas unpredictably. As ice turns to gas and erupts from the surface, it creates tiny, random thrust forces, like a sputtering, out-of-control rocket engine. These small nudges continuously alter the comet's trajectory, making long-term predictions incredibly difficult. If a comet were ever found to be on a collision course with Earth, we would need to track it with extreme, unwavering precision to plan any kind of deflection mission. 3I Atlas, with its prominent tail, its active coma, and its complex behavior, is the perfect test case. It is close enough to be observed in detail by ground-based telescopes, but far enough away to be completely safe. And its inherent weirdness challenges our observation techniques, forcing us to get better. The IAWN campaign is focused on improving astrometry, the science of measuring celestial positions and movements. They are holding workshops, comparing different tracking techniques, and calibrating instruments across dozens of observatories. They are treating 3I Atlas like a practice run, a global fire drill for a threat we hope never materializes, but know, on a long enough timeline, is inevitable. What's truly inspiring about this is how it connects to our daily lives. We all have comets in our future, unpredictable challenges that we know are coming, but we don't know when or in what form. It could be financial instability, health issues, or societal changes. The lesson from the IAWN is to not wait for the crisis to happen before you prepare. They are using this safe, distant object to build the skills, the networks, and the protocols they'll need when the real thing is bearing down on them. We can do the same. We can practice on smaller, manageable challenges to build our resilience, our skills, and our support systems, so that when a civilization-level threat appears in our own lives, we know how to track it, how to predict its path, and how to act. They're even asking citizen scientists for help, a reminder that we all have a role to play in protecting our collective future. Registration closes November 7th. It's a rare chance for anyone with a decent telescope to contribute to genuine planetary defense. As 3I Atlas continues its journey, preparing to swing past Jupiter and then head back out into the void, its legacy is already being written. It will soon fade from our telescopes, becoming a ghost in the darkness once more. By early 2026, it will cross Jupiter's orbit. By 2027, it will be in the realm of Uranus and Neptune. And then, silence. It will return to the interstellar ocean, but this time it will be different. It will carry a part of us with it, particles from our sun's solar wind embedded in its ancient ice. its molecules subtly altered by our star's heat. It will be an emissary, carrying an infinitesimal trace of our solar system on its endless journey. Billions of years from now, should it ever encounter another star system with curious inhabitants, they might detect those traces and wonder what kind of system it visited so long ago. The answer is, a system that noticed, a system that watched and learned and questioned. 3i Atlas has forced us to confront the profound limits of our own perspective. For all of human history, we have studied comets from one star system, our own. We have built all our models on this sample size of one. This object tells us that our cosmic neighborhood might not be the universal standard. What is normal for a comet from a metal-rich star, or a system with a different planetary configuration? 3i Atlas might be perfectly normal for where it came from. It's just that its home had a different set of rules. This is simultaneously the most boring and the most exciting explanation. Boring because it means no aliens. Exciting because it means every interstellar visitor is a unique window into a stellar system we will never see, a direct sample of the galaxy's incredible diversity. This is perhaps the most important lesson of all. We often judge the world based on our limited experience, our sample size of one. We assume our way of life, our culture, our beliefs are the default, the normal. An encounter with someone from a completely different background can feel like meeting an object with impossible chemistry. Their behaviors and beliefs can seem anomalous. The lesson of 3i Atlas is to resist the urge to label them as wrong, and instead ask, what kind of environment, what kind of history produced this way of being? It's a call for cosmic empathy. Every person we meet is a visitor from a different system of experiences. By studying them with curiosity instead of judgment, we learn not only about them, but about the vast and varied universe of human possibility. 3i Atlas is a messenger. It's telling us that the galaxy is more connected than we ever dreamed. That material, the very building blocks of planets and life, flows between star systems. It is telling us that our theories are incomplete and that the universe still holds surprises that can shatter our paradigms. And it is reminding us of our own resilience. It survived the sun's fury. We too can survive the storms in our lives, hold to our trajectory, and continue our journey. So what happens now? The Vera C. Rubin Observatory is set to begin operations in 2025, and it's predicted to find one or two new interstellar objects every year. We are on the cusp of a new era of astronomy, where these visitors will become commonplace. NASA and other agencies are already designing missions to one day intercept one of these objects, to land on it, to sample it directly. The dream of touching a piece of another star system is closer than ever. As this extraordinary visitor prepares to leave us, I want you to think about the mysteries in your own life, the things that don't add up, the anomalies that defy your explanations. Don't be afraid of them. Don't dismiss them. Look closer. Ask harder questions. Be willing to entertain the wild hypothesis. That is where discovery lies. That is where growth happens. The universe is not trying to confuse us. It's trying to teach us. 3i Atlas is one of its most profound lessons. It has reminded us that we are part of something so much larger than ourselves, a galactic web of cause and effect, of wandering and returning. And the simple fact that we are here, aware and curious enough to notice its passage, is perhaps the greatest wonder of all. What do you think is the most likely explanation for 3i Atlas's strange behavior? Is it just a very unusual comet? Or do you think the possibility of something more is worth considering? Let me know your thoughts in the comments below. Thank you for joining me on this journey to the edge of understanding. Take care of yourselves and be well. And if you found wonder in this story, please consider subscribing to the channel for more explorations into the mysteries of our universe.